Hi everyone, this is a continuation of the notes. So this is the rational root theorem, and the rational root theorem says the complete list of all possible rational roots of a polynomial is the ratio of all the factors of a constant term divided by the factors of the leading coefficient. And we did example 1 together in class. And come on, adjust, sorry about that. Okay. So here are all the factors of -6, the factors of +6, and then here are all the possible combinations. Then instead of plugging all of these into synthetic division, we went to the graph and we used the graph to help us, okay? So that's what we're going to do. And your job was to finish examples 2, 3, and 4, and you can watch the video or you can just do them on your own and check your answers. So here we go. Use the rational root theorem to determine the rational roots for each of the functions below, and then use synthetic division to verify that they are, in fact, roots. It didn't say to use Desmos, but we are. All right. So what we're going to do is we're going to list the factors of 10. Okay, so the factors of 10 are going to be plus or minus 1, plus or minus 2, no 3, no 4, plus or minus 5, and then plus or minus 10. Okay, those go in the numerator. And then we're going to divide it by the factors of 6, which we already found above. Plus or minus 1, 2, 3, and 6. Now what we're going to do is we're going to list all the combinations, and let's do it in an organized way because we're mathematicians. So we're going to start with 1 and do all these denominators, then go to 2 over these 5, 10, and there's 2 key factors, okay? 2 key factors. Ready? Reduce all the fractions and then don't repeat. So if you have 2 over 2 is the same as 1 over 1, we're not going to write it again. Okay, ready? Get set? Here we go. 1 over 1 is 1. 1 over 2 is 1/2. 1 over 3, and then 1 over 6. And we can do it in rows like this. I don't need a double negative there, do I? It's like I was trying to make a fraction out of that plus or minus. And then I didn't even do, yep, that's how tired I am today. Here we go. All right, that's our 1s. Now we're going to go to 2s. Ready? 2 over 1 is 2. 2 over 2, 2 divided by 2 is 1. We already have a 1, so we're going to skip it. We don't need that. We don't need to write it twice. 2 over 3 is 2/3. 2 over 6. What does 2 over 6 reduce to? Does it reduce to 1/3? Okay, so we don't need to rewrite that. So that's it for the 2s. We had 2 repeats. Okay, let's do 5s. Ready? Plus or minus 5 over 1. Then we have 5 over 2. We haven't seen that yet. We have 5/3. We haven't seen that. And then 5 over 6. So those are all new. No repeats there. Do you do your fractions like that or do you do them like that? It doesn't matter. Okay, last but not least, the 10. 10 over 1. What's 10 divided by 2? 5. Do we already have a 5? Yes. 10 over 3. That does not reduce. We're going to leave it as 10/3. What about 10 over 6? So if you're not doing anything in your head, just do them over here in the margin. 10 over 6 is 5/3. We already have 5/3, right? Okay, so here are all the possible rational roots. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 times 2. 24. Do you want to do 24 synthetic divisions? No way, Jose. That's way too much. All right, so now we're going to go to Desmos. And if you have Desmos on your phone, it's a lot of fun. So let's see. Here's Desmos on my phone. Loading, loading. thinking about starting. There it is. Okay. 6x to the power of 3 plus x squared minus 31 plus 10. Oops, 31x. This is a good app here. Okay, there's my graph. Sorry if it's hurting your screen. Try and, let's see. All right, where do we think these are hitting the x-axis at? I think if we just touch the zeros, it will give it to us. So we have negative 2.5, positive 1/3, and positive 2. All right, we'll get my phone out of the way. And it's a positive cubic with a y-intercept of 10. So that's what it looks like, and the y-intercept's 10. There we go. Isn't that beautiful? Okay, and what are we going to do? We're going to use synthetic division to what? To verify. We already know what the zeros are. We use the calculator, but we're going to verify. What is this point at? Is that supposed to be at... Oh no, it's supposed to be at negative 2.5. Okay, so negative 2.5 is what fraction here? What's negative 2.5? Is that negative 5 halves? And we're going to do a synthetic division to check. Okay, ready? Negative 5 times 6, negative 30 divided by 2. Negative 5 times negative 14. That should be 5 times 10 is 50. 5 times 4 is 20. So 50 plus 20 is 70. Oops. And then we're going to divide by 2. So 70 divided by 2 is 35. And a negative times a negative is a positive. Here we go. 4 times 5 is 20. 20 divided by 2 is 10. And we verified. How do we know? Because we got a 0. Okay, this was 0.33333. What fraction is that? 1/3. Here we go. Positive 1/3. 6, 1, negative 31, 10. 6 times 1 divided by 3. 2, 3. 3 times 1 divided by 3. 30, sorry. Okay. 1 times negative 30 divided by 3. Check. And then the last 0 was 2. So we have 2, 6, 1, negative 31, 10. Bring down the first term. 2 times 6 is 12, 13. Isn't this lovely after doing fractions? And you can go much faster. 4 plus 1 is 5, so it's a negative because the bigger one's negative. And that's how we know. All right, ready for the next one. Ah, oh my gosh, I used my master copy. So, ta-da, power of magic of TV. Ready? Get set. What goes in the numerator? The factors of 3. 3 is a prime number. Oh my goodness. 3 is a prime number. That means there's only 2 choices, 1 and 3. Isn't that nice? Okay, what about 18 though? That has a lot of numbers. A lot of factors. 1, 2, 3, 4? No. 5? No. 6? Yes. 7, 8, 9. You know, did you ever do factor rainbows? Okay, 3 times 6, 2 times 9, 11, 1 times 18, I mean. Okay, here we go. Ready? Get set. What is this equal to? 1 divided by 1. 1. 1 over 2. 1 over 3. 1 over 4. Nope, not 4. 6. Just kidding. 1 over 9 and 1 over 18. I wonder what... That's a funny one, right? Okay, now we go to the 3's. 3 over 1. 3 over 2. What's 3 over 3? 1. So we don't have to write that. What's 3 over 6? 3 over 6, 1/2. Oh, we already have that. We already have that. Yes, that's what I meant. 3 over 9. 3 over 9 is 1/3. Do we already have that? Okay. 3 over 18. 3 over 18 is 1 over 6. And we already have that. Oh, so we were done. I wrote too much. Okay. Ready? Desmos. Let's do it. So this is my phone. You can be using the online version or use your own phone. The best way to start a conversation in a social setting is to say, hey, have you seen this new app called Desmos on my phone? Let me show you what it can do. Ooh, there's only 2 here. Do you guys see that? What do we have here? Negative 1.5 and 0.333 again. And that looks like a multiplicity of 2, right? A double root because it bounces. How did I do on my y-intercept? Watch, this is how you fix your y-intercept. What's it supposed to be? 3? There you go. You just label that. Hey, that's 3. That's what you get for not putting numbers on my y-axis. I get to make them up. Okay, what are we checking here? What was this? Every time I turn the phone off, I forget what that number is. It should be is it negative 1.5? Yeah, so this 0 right here, negative 1.5. What fraction is negative 1.5? 3 over 2? Oh, but we're going to do negative. So negative 3 over 2. 18. Are we missing any terms? Oh my gosh, were we missing any terms before? No, because it wouldn't have worked out. How do we know it's going to work out? What are we supposed to get here? A 0. Bring down the first term. Okay, ready? You know how I was multiplying? Gosh, these numbers get so big, so I'm going to divide instead. So what's 18 divided by 2? 9. 9 times negative 3. You can do that? Yeah, Miss. Yeah, you can. Multiply and divide in the other order. So divide first, then multiply if the numbers get too big. I don't want to figure out what 3 times 18 is right now. I'm tired. 27 and 15. Let's see. 5 gets me to 20 and then another 7. So 5 plus 7 is 12, but it's going to be negative. Synergy. Uh-oh. Okay. There we go. Ready? Let's do my other trick. Ready? Negative 12 divided by 2. Divide first. Negative 6. Negative 6 times negative 3 is a positive 18. And that's nice because that's going to be 2. Okay. You want to do it the other way now? 2 times negative 3 is negative 6 divided by 2. Negative 3. Check. And what fraction was this? Remember it was 0.33333. So what fraction does that match up with? Positive 1/3. Okay, we're almost out of time. This should be a double root, right? So what that means is we should have a 0 twice. So 18 divided by 3 is 6. 15 plus 6 is 21. Divided by 3 is 7. Negative 16 plus 7 is negative 9. Divided by 3 is negative 3. Check. How do we know if we did it right? Or if it's a double root, we do it again. But we have to do it again with these. All right. 18 divided by 3, 6. 27. 27 divided by 3, 9. Beautiful. Okay. It's sad, but we need to... I'm running out of time. So powers of 6 on the top, and then the powers of 8 on the bottom. 1, 2, 3, 4, and 8. And then we're going to start listing all the combinations, and we'll have to check the answers. Wait, I'm going to pause it, and then I'll post. Okay, I paused, I graphed it, and we have negative 0.75, negative 0.5, and 2. So here are the fractions. Go ahead and pause and get those synthetic divisions down, and we'll move on tomorrow.